Okay, so we're going to talk about the movement of fluids and the exchange of tissue fluid at the capillary. So this is a capillary that I'm drawing here, and this is going to be my arterial end of the capillary, and this is going to be my venial end of my capillary. So blood is going to come from the arterial end through the capillary to the venial end. And we're going to have fluid in the blood passing into the tissue at the arterial end and then back into the capillary at the venial end. And we're going to explain how this occurs. Okay, so there is one type of pressure that is exerted on the tissue, and that is called hydrostatic pressure. So hydrostatic pressure is the pressure that the blood has against the capillary wall. And a good example of hydrostatic pressure would be, say, for example, filling up a balloon of water and puncturing some holes in this balloon. Water would spurt out of the balloon as there's a high hydrostatic pressure inside the balloon. And pressure is measured in kilopascals, kPa. So let's keep the numbers really simple for the time being, even though these numbers are unrealistic. Let's imagine we have a hydrostatic pressure of 10 kPa, kilopascals, in the capillary and 2 kilopascals in the tissue. In order to work out our net pressure, our net hydrostatic pressure, we are going to do 10 minus 2, which is going to give us 8 kilopascals. Then we've got another type of pressure that is exerting itself on the fluid, and that is something called oncotic pressure. And just to explain a bit about oncotic pressure is the pressure that fluid will have when placed near or in solutes. Now, water or fluid wants to move to an area of high solute concentration. So let's imagine this is the capillary, this is the tissue. The fluid will want to move back into the capillary as there's a high solute concentration. So if there were no solutes in water, then this would be considered 0 kilopascal. If there are solutes in the fluid, then it's going to be given a minus figure. So in this case, you might say, for example, that inside the capillary there is a minus 5 kilopascal. If I was to have some solutes here, maybe this would change to minus 1. If I was to have loads of solutes, maybe this would change to minus 10. So the fluid will always want to move to the more negative high solute concentration. Okay, so what we need to be able to do then is we need to be able to have a look at these two types of pressure. So we do have some solutes obviously in the capillary, in the blood, and there are some solutes in the tissue, but not as many. So let's say we've got, again, I'm going to use some simple numbers, minus 2 and let's say minus 5. Then what we're going to need to be doing is working out what our net oncotic pressure is going to equal, which is going to be minus 5 minus 2, and that's going to give us an answer of minus 3. So we have our net hydrostatic pressure of 8 kilopascals and our net oncotic pressure of 3 minus 3 kilopascals. So then we need to get the overall net pressure. So this is going to be 8, which is our hydrostatic pressure, plus minus 3, which is our oncotic pressure, and that is going to give us 5. So therefore, we are going to have the movement of fluid out of the capillary at the arterial end. So now if we move over to the venal end, let's see what ends up happening at this point. So what's going to have happened is the hydrostatic pressure is going to have reduced. So let's say the hydrostatic pressure reduces, and now we've got 3 and 2. And our oncotic pressure is going to stay the same, minus 5, minus 2. So this is our hydrostatic pressure, this is our oncotic pressure. So we need to work out the net hydrostatic pressure. So that is going to be equal to 3 minus 2, which is going to give me 1. So my net hydrostatic pressure is 1 kilopascal. Then I'm going to need to calculate my oncotic pressure, net oncotic pressure, which is going to be minus 5 minus 2, which is going to give me minus 3. And then my overall net pressure, which is going to be 1 plus minus 3, and that is going to give me minus 2. So I'm going to have now an overall pressure that is going to cause the fluid to return back into the capillary. It's worth mentioning that some of the fluid does not return back into the capillary and it is drained into the lymph system, but we will talk about that in another video. Okay, so now let's have a go at looking at more realistic numbers for this situation, and then you can have a go at seeing if you can work out some of this yourself. So let's imagine I have a capillary here, and I've got my hydrostatic pressure here, which is, I'm going to say 4.3, and my hydrostatic pressure in the tissue, which I'm going to say is 1.1. I've got my oncotic pressure in the capillary of minus 3.3, and my oncotic pressure in the tissue, which is going to be minus 1.3. So if you can try and work out what your net hydrostatic pressure is going to be, your net oncotic pressure, and then your overall net pressure, and then you'll be able to identify whether this is the arterial end or the capillary or the venal end. So pause the video and have a go at this. Okay, so hopefully you've done that. So our net hydrostatic pressure is going to be 4.3 minus 1.1, and that is going to give us an answer of 3.2. And then our net oncotic pressure is going to be minus 3.3 minus 1.3, and that is going to give us minus 2. And then our overall is going to be 3.2 plus minus 2, which is going to give us 1.20. So therefore we are going to have the movement of fluid out of the capillary, and so therefore this is going to be the arterial end of the capillary. Okay, so let's have a look at another one. Let's change these numbers. let's say that we have a hydrostatic pressure of 1.6, a hydrostatic pressure of 1.1 in the tissue. Ontotic pressure, we're going to keep the same. And you've probably already guessed this is going to be at the venial end. But if you try and calculate net hydrostatic pressure, net oncotic pressure, and then overall net pressure, and then pause the video and have a go at seeing if you can calculate this. Okay, so hopefully you've done that. So our net hydrostatic pressure is going to be 1.6 minus 1.1, which is going to give us 0.5. Then we're going to have our net oncotic pressure, same as it was before, minus 3.3 minus 1.3, which is going to give us minus 2. So then we're going to do our overall pressure, which is going to be 0.5 plus minus 2, and that is going to give us minus 1.5. So we are going to have the fluid being drawn back into the capillary, and so therefore, as already mentioned, this is going to be at the venial end of the capillary.